Hello Legacy students! So today we're going to look at graphing polynomials. As you can see, this video is a little different than normal just due to the fact we're going to be using the TI calculator today. So you're definitely going to want a graphing calculator to play with as I show you some of the ins and outs of finding some of the information. So, learning targets for today. What do you need to be able to do by the end of this video? Basically, the focus is graphing a polynomial function. Now, graphing polynomials, you do require technology. That's why we're using the graphing calculator. Also, we're going to identify our key features such as end behavior and various information that we've done already. So, number one thing is noticing there's a pattern to polynomial functions. So what I would like you to do is pause this video and I want you to graph those four functions here quick and see if you can find out anything, just kind of even just looking at the graphs. What do they generally look like? Do they both do a certain end behaviors? What's with the leading coefficients? Because some of them it seems that the leading coefficient is negative, some of them have it to be positive. Is there something special with that? So pause right now and take a look at those. So you should be back from looking at your graphs here. I'm going to show you pictures here. So here are my pictures, my graphs of those particular graphs that you just took a peek at. Now notice something that I see. I notice, let me start my ink here. I notice that if it's a squared or to the fourth, notice they're both going the same way. It looks like a parabola in all actuality. Cubes or fifth, they kind of look like an S if you turn your head to the side. It's kind of a strange S, but nevertheless, notice these are going different directions, as well as these negatives are going to affect the way our graph is going. That's a couple of things you're going to want to pay attention to as we continue on. So, pattern recognition. What have we figured out? Well, end behavior. We know about end behavior now. We know that if it's an even highest exponent, they're both going to go the same way, right? However, if it was an odd exponent, they went different ways, right? One went up, down, that kind of thing. General shape, well, same thing, even and odd. Even did some form of a U. Sometimes you'll see them also do like a W shape, depending. You didn't see any of those, but we will look at one of those kinds today. Odd is always going to do some form of like an S or a squiggle. Sometimes it might be a little bit more squiggly, but it's always going to look something like that. Leading coefficient sign. We didn't really look at that, but notice, guys, how it starts at the beginning. Going down, right? This one's going up. So it's basically a flip from what it looks like it should do normally. So that's going to tell you if it's going to start normal or is it going to flip in that regard. So this tells you, especially on the evens, you know that you're going to be pointing down. If it's an odd, you know you're going to be pointing up at the beginning. So I have a cool little, you should grab out that little foldables. Two of them I gave you. The little one, glue both of these into your notes. However, this one with the calculator on that, you're going to want to fold on the dotted line and then title it Finding Extrema with a TI-84 calculator. What I did is I took basically the steps of how we're going to find extrema on the calculator into a foldable for you guys so you can reference it back. So, end behavior polynomials. Here's something that we're going to want to remember. So if it's a positive leading coefficient and an even degree, so that means you're going to be going up on both sides of my graph. It's going to do something like this. Whee! It's going to do something like that. If it's a negative leading coefficient, you're going to go down on both sides if it's even. So it's going to go something like this. Whee! Odd degree, what's going to happen if it's a positive? It's going to go down on this side but up on that side. So it's going to do something like this in that grade. So if it's odd degree, it's going to go down, start from the bottom, go up. If it's a negative, that's going to flip that and go from top to bottom. Something like that. So keeping that in mind, honestly, to keep that in mind is to know if the graph on the calculator is actually giving you what it should be giving you. The TI calculator. This is more for your guys' knowledge of how to type into one of the calculators. So the very first thing that you're going to want to do is to kind of take a look at when we're graphing here. I'll use these steps and I'll refer back to these steps each time that we use them. Alright, so let's graph our polynomial. So x cubed minus 4x squared minus 9x plus 36. There's a couple of things you can decide upon right now before you even start to graph. Degree. What this is a word for the highest exponent. So if you want to make a note of that on your notebook. Degree is just a word for the highest exponent. So in this case, our polynomial is a third degree polynomial. That's the highest exponent present. Number of possible roots. This is always going to match degree. Because, guys, remember, possible roots, that meaning how many x-intercepts can this thing have? Well, it can have the highest exponent amount, right? 3. Max number of turning points. Turning points, what that is basically when does it change from increasing to decreasing? And that's always going to be 1 less than your degree, which in this case would be 2, because it'd be 3 minus 1. So this thing can change direction twice. Now, here's where we're going to have to start using the graphing calculator, because what we need is at least a couple of x-intercepts, right? So let's flip to the next page here. Let's find ourselves a couple of x-intercepts, aka let's see if this particular equation factors. So let's group these guys, looks like an x squared can come out of there. That's x minus 4. Looks like I can take a negative 9 out. That's x minus 4. Got x squared minus 9 on the outsides, x minus 4. Oh, x squared minus 9 though, that does break down into x plus 3, x minus 3. Don't forget those difference of cubes. So my x-intercepts are located at negative 3, 3, and 4. So ultimately, if I go to my back page here, we said negative 3, 3, and 4, right? Yeah, those are the ones we said. So I have those for my dots. Let's also find a y-intercept. Remember, to find a y-intercept, all you do is plug in 0 for x. So if I get 0 cubed minus 4 times 0 squared minus 9 times 0 plus 36, I'm going to get a y-intercept of 0, 36. That's a pretty big number. Can't do much more. Let's actually do some graphing here. So I'm going to go over my graphing calculator. I'm going to turn him on. First thing, there we go. As you can see, guys, I do have my key press history up here for you. So we're going to follow those steps here. So first of all, we're going to go into the y equals button right here. And we're going to type in the function. So x caret cubed, arrow over, minus 4x squared minus 9x plus 36. And we're going to push the graph button. So it should give us a pretty cool graph. Notice, guys, so we have this kind of going up. Since it is a positive exponent, we know it's going to go bottom to top, right? And it's going to do it like an S shape. Notice I'm missing the upper bump up here. I don't have that on my graph, but I do have the lower bump. So what we're going to do is we're going to click zoom. We're going to go 6. What that should do is turn you back to a 10 by 10 graph if you weren't on there already, so you should have the exact same graph as me now. Now, you're going to have to kind of play with it so you can get a better graph. This is the only part that's not on that little cheat sheet I gave you for graphing calculators. So we're going to click window here, and we're going to see if we can get that topper bump. What window allows you to do is to change what's the lowest x value shown, what's the highest x value, and so on and so forth. Well, I don't really need to change the x values, but I do need to change the upper y value, right? Because we need to get all the way up there. And I know that there's going to be a y-intercept of 0, 36. So I know it's got to be pretty high. So let's try a maximum of like 45. Something bigger. I just know I need to be bigger than 36. So I'm going to try something bigger than that. Y scale means it's going to count by ones. Since I'm going from -10 to 45, I think I'm actually going to change it to a scale of 5. So that means every little tick mark is going to be worth 5. Let's click graph now. Let's see if we get a better graph. There we go. So notice, guys, now you're able to see the humps on both sides, so that's good. What we're basically now going to do is find our extrema. In this case, my local extrema. So here's where we're going to go back to your little calculator sheet. We're going to go to second trace. Second trace. It's technically the calculate button. And we're going to option 3 first. We're going to define the minimum. Now, here's the part that people struggle with. What you're going to do is you're going to move to the immediate left. So what does that mean? You're going to move the little guy. You see the little turtle here? He's kind of running around. You're going to move him to the left of the minimum. So I'm on the left of the minimum. I'm going to push enter there. Now he says, hey, go to the right side of the minimum. So I'm going to arrow over, make my turtle go to the right side of the minimum. Push enter, and then you're just going to press enter again. What it should do is pull up the minimum for you. I'm going to make a little note of that on our thing here. My minimum is at a point of, I'm going to put min, I have 3.5 comma -1.6 roughly. Okay, now let's do the same thing. Now we're going to have to do second calculate. We're going to go find the max now. So then they say left side of the max. You're going to move your little turtle. You're going to move him to the left of the max, right about there. Move to the right of the max. Your max isn't, your left and right don't have to be exact. You just need to be on the left and the right. Push one more time. There we go. So I know my maximum is at -0.9 roughly, comma 40.1 roughly. There we go. And those are both my locals, right? Because I know my absolutes would be, my absolute minimum would be -infinity, and my absolute maximum would be infinity. If you know that, remember that. So I'm going to go over to my graph here, and I'm actually going to be able to connect through my dots here. So let's go ahead. I'm going to do those 2 dots here. Negative. So I know my maximum is somewhere way up there, so we're just going to put a dot up there. And then we said our minimum was at the point 3.5, -1.6, so we can actually kind of graph that one. 3.5, -1.6, something around right there. So I know my graph's going to do something like this. Connecting all the dots, of course, better than I can do. So Now I have a graph. Let's go ahead and do some information here. Even, odd, neither. Remember, even means it folds along the y-axis. Odd means the diagonals match. In this case, none of them, so we're going to say it's a neither. Intervals of increasing. Notice there's quite a bit of increasing and decreasing going on in these graphs. Well, increasing, it looks like I'm increasing from negative infinity to, oh, what's that x value? That x value was negative 0.8 or 0.9, I think we wrote down. There we go. And then I also am increasing from, looks like 3.5 to infinity. And then I am also decreasing from negative 0.9 to 3.5. So that's why these numbers are important. It's for our intervals of increasing and decreasing. That's why we're trying to find our maxes and our mins to the best of our ability using the calculator. And behavior, similar to exactly what you did for parabolas. But they just won't match every time. So as my x goes to negative infinity, aka as I go this way, my graph is going downwards to negative infinity. But as I go to positive x's, I go positive y's. And finally, let's find the domain and the range of our graph. So domain, no issues on domain. So negative infinity to infinity, it looks like. Range, no problems there. And then continuous and bounded. We are continuous, definitely continuous. And we are not bounded, because that goes forever both ways. And that's the end of this video. We'll do one more in class so that you feel comfortable, especially with the graphing calculator portion. But until then, see you later, Sabers.